Hello everyone and welcome to MakeLearn 360. So in this video I want to solve a question with you to illustrate the concept of the oblique axis. Okay, so let's read the problem together and solve it. So we have the first part of the problem says that a 1060 kilonewton load P is applied to the granite block shown. So we are to determine the resulting maximum value of the normal stress and then the shearing stress, as well as specify the orientation of that plane on which these maximum values occur. Alright, so basically there is a formula for calculating the normal stress. Let's say there is a plane, some arbitrary plane, which where there is a section actually. Now what happens is that there is a formula for calculating the normal stress, which is given by the load divided by the original area, cosine squared of the angle. Okay, now this angle is actually the angle that the angle of inclination or the surface mixed with the normal. Okay, so let's say if there was a normal axis here, what would be the angle of inclination? Okay, that is the theta. All right, so this is the formula that we have, but then we know P as 1060 kilonewton, and we also know the area as 140 by 140 mm. So what is 140 mm by 140 mm? That is going to be, so 140 multiplied by 140, that gives us 19,600 millimeters squared. Okay, so in fact the maximum value of this one is the same as answering the question of what is the maximum value of cosine squared theta. Okay, in fact the maximum value of cosine squared theta will actually occur at theta to be 0. All right, so the value of the maximum stress will be 1060 times 10 to the power 3 kilo divided by 19600 millimeter squared. Then cosine squared theta. In fact, the maximum value of the stress, in fact this is actually a compressive stress, the maximum value of the stress will occur when the angle of inclination is exactly lying on this normal. In other words, the maximum value of the normal stress is when the load is applied perpendicular to the surface. So that is to say, if theta is actually 0. Okay. All right, so it means that we will just substitute cos 0, and interestingly cos 0 will be 1. So then the normal stress will be so 1060 times 10 to the power 3 divided by 19,600. Okay, now this is the normal stress, which is 54.08 megapascal. Don't forget that whenever you are dealing with Newton per millimeter square, it is the same as megapascal. All right, again the question is saying we should find the maximum. Okay, so find the maximum normal shearing stress. Now the formula for the shearing stress is given by the load P divided by the original area multiplied by cosine theta and then sine theta. All right. So now for this formula, if you want the maximum value of the shear stress, cos theta sine theta can be thought of as using the trigonometric value, which is the same as, all right, now using the is the same as using the double angle formula, which is sine theta plus theta is going to be cos theta sine theta plus sine theta cos theta. So simply put, 2 sine theta cos theta will be the same as sine 2 theta. Interestingly, what this means is that if I have cos theta multiplying sine theta, then it is the same as sine 2 theta divided by 2. So I can rewrite the shear stress as P divided by A naught, so 2A naught into sine 2 theta. Now the question is, where does the maximum value of sine occurs? Interestingly, the maximum value will occur when sine is actually 90. Therefore, for sine to be 90, then 2 theta will be 90, so that theta will be 45. So in fact, what this is telling us is that the maximum shearing stress will occur when 2 theta is 90 or theta is what? 45. So we can go ahead and say that our maximum shear stress will be the load, which is what? 1060 times 10 to the power 3 divided by 19,600, and then sine sine 90, which is actually 1. Then I multiply here by 2. All right. So in fact, that is it. So the question said we should calculate the normal stress and the shearing stress and then specify the orientation of the plane. So that is where the specification is coming from. Therefore, we can say that the normal stress will happen at exactly theta equals 0. That is where the normal stress will happen. And the shearing stress, the maximum value will happen at theta equals 45. And then the value is given by, again, let's calculate it. It's going to be, so I'm not going to change anything, but I will just divide here by 2. All right. So the maximum value of the shearing stress is going to be 27.04. So 27.04 megapascal. And that is the maximum value of the shearing stress. And it occurs at theta equals 45. And then the maximum value of the normal stress is 54.08 megapascals. And it occurs at theta equals 0. Okay. So this problem has been solved. But then with the second part, so let's look at the second part of the problem. Okay, so now the second part of the problem is actually simple, and it's a follow-up to the first question. So it says that a centric load P is applied to the granite block shown. Now, knowing that the resulting maximum value, so listen to this carefully, the resulting maximum value of the shearing stress in the block is 18 megapascal. We should determine the magnitude of P, the orientation. All right, so let's solve it one by one. So the first thing we want to do is that we know that the maximum shearing stress is given by P over 2A naught sine 2 theta. Okay, so this is the general formula actually. but the maximum shearing stress is when theta is 45 degrees. We just saw this. This is because sine 2 theta is maximum where theta when the value of the sine takes 1, and if you take inverse of both sides, you end up getting theta equals 45. So this has been already established. Now the question is saying that the value for the shearing stress, which is maximum, is 18. Okay, so we should find the load. So this one is very simple. We know this one, so it's going to be 18 megapascals should be P divided by 2 multiplied by the area, which is 19,600. So the value of P, so we know the okay, so we know the stress. Okay, yeah, so we know the stress, and then we have this one. Okay, so we can say that our P, which is the load, is going to be 18 multiplied by 2 multiplied by 19,600. So what is this? So this one is going to give us so our load, let's pick our calculators. This one will be 18 multiplied by 2 multiplied by 19,600. So 1, 2, 3. Okay, so 1, 2, 3. So 705.6 kilonewton. In fact, this is the load. Okay, so we have solved the first part of the problem. The first part of the second problem. And then the next part says that we should find the orientation of the surface on which the maximum shearing stress occurs. Oh, so that is 45. We don't really need to solve it. That is the theta. Theta is 45. That is all. And then we should go ahead and calculate the maximum shear stress at that point. Okay. So now, since we know P, the question is saying that for this time round, we know P, and P is the maximum. P is coming from the maximum shear stress. So then the question is saying that we should go ahead and then find the normal stress on the surface. So now we are going to find the normal stress on the surface, but we are going to use so we are going to use what we have just gotten. So the normal stress will be P divided by A naught cosine squared theta. That is the formula for the normal stress. If we put this 705.6 times 10 to the power 3 divided by A naught, which is 19,600, and multiply by cosine squared of 45, which we just got for the second part, then the normal stress is going to be, let's pick our calculators again. This one will be 705.6 times 10 to the power 3, 19,600, and then this will be multiplied by cosine 45 squared, and this gives us 18. Okay, all right, so that is interesting. So 18 megapascals, but then it's actually going to be negative because it is a compressive stress. Okay, so the answer is actually minus 18 megapascal. That is the compressive stress. Okay, and the last part of the problem, where he said okay, no, the last part where he said the maximum value of the normal stress. Okay, so again, the formula for the normal stress is equal to P A naught cos squared theta, and we said that the value of cos squared theta will be maximum when it is exactly is equal to 1, where theta can be 0. Okay, so in fact the answer is that for the maximum normal stress, that is P over A naught. In fact, this formula is also called the average normal stress. This is interesting. Okay, so what do we have then? So all what we are trying to say is that when the angle is 0, we get the maximum normal stress, and then when the angle is 45, we get the maximum shear stress. That's all. So it's going to be P, which is 705.6 times 10 to the power 3, they're divided by the area, which is 19,600. So we will get so let me just remove this one. So 36 megapascal, that is the normal stress for you. So this problem has been solved, but because it is a compressive stress, we need to also negate it again. Therefore, our normal stress is minus 36 megapascals. All right. So this problem has been solved. Thank you very much for watching. If you have any question, please leave it in the comment section. Thank you.